Okay, I don't know why it's taking a lot of time because, please, I want to start with the prota. It will help us to understand much as we move to ETABS because I don't want to explain ETABS using prota. I want to explain prota using ETABS so that when we go there, it will just take us like 20 or 30 minutes. Then you'll have understood everything in ETABS. So let's be patient a bit. Is it patient? Yes, patient. should be taking like 1 to 2 minutes to install, but I don't know what's happening today. So what we will do, let's just continue with the ETABS. Now, a good practice is to teach you guys or to discuss this thing using prota, and then from prota to ETABS, it will be so easy. Okay, after opening ETABS, the first window that you will see is this one. So what are you going to do with this window? Of course, this one will give you an opportunity to open a new model or to open an existing model. For example, if I have an existing model inside this laptop and I want to design that model, for example, I don't know if I have, and I don't have any software. But if you have any model, for example, someone has sent you a model, then you want to open, of course, you just come here, then browse that folder and then open. But for us, we want to open a new model. Immediately we press open a new model, then we are going, the software is going to allow us to set the code that we are going to use. And that one will also apply to protostructure. So we'll first of all click this open new model, this one. Then this model initialization, this one will allow you to set or to select the code. So what we are going to do here, you'll come here to use built-in settings. So use built-in settings means we are going to select the code according to how these guys have coded the software. So here you'll just come here to use built-in settings. Then at this point, you'll use US customary. As you can see, we have US customary. US customary, this one is the imperial units. Then we have the metric SI units. This one is the international standard units. Then we have the metric MKS units. This metric MKS units is mostly used by the Germans and the France guys. Why? Because most of their loads are given in kilograms per. Not for our case, we always use newtons or kilonewtons, but these guys are still using mass per meter squared, something like that, mass per square meter or per square something. So for us, we are going to use metric. Then the region. Now, as you can see, we have the Australia, Canada, China, Europe, India, and so on. But for our case, we don't have even one African country, including we don't have South Africa or even Egypt. So what are you going to do? Are you going to select the Europe? Of course, no. We are not in Europe, in UK or also. So what you are going to do here, kindly select user defined settings, this one. Then for the steel, of course, we are not going to design the steel structures for this project, but for the steel, we can always use BS. We can always use these shapes from BS 206. This one. Then for the steel code, now the code, this one is the database, but for the code, we can use BS 5950. This one of 2000. We have BS 5950 of that year 19 something, but you have this one, updated one of 2000. Then now for the concrete, we have Eurocode 2 and the BS 110 for most of the African countries. But now, which one are you going to use? BS 110, this one of 1997. Of course, we have BS 110 of 2002, but if you go to that BS, actually there's nothing new. Nothing new in that BS. So after that, click OK. Immediately after doing these settings, so please pay attention, because now I wanted to explain much of the things using protostructure, but now let's just rely on this and and do something. So here, the first thing is to set the story, to set the building, to customize this window, this new model quick templates, to customize it to suit your model, your layout. So how do we customize this? The best practice is to do what? Is to use the grid, this one, to custom grid spacing. Use this one. Then, and remember this, I just created a very simple, this one is a very simple model that you can just go direct. You can just go use the direct ways in ETABS. But I'm going to show you the other shortcut, provided that you are handling a very complicated and complex building. But for this simple building, you can just use the direct ways, of which I'm not going to show you that one today. Now, After selecting the custom grid spacing, the next thing is now to come here and set the story data. How the number of stories. As you can see from this this one, we have story 1, 2, 3, 4, then roof. So we have 5 stories. So here we have 5 stories. Then the typical height. Do we have the typical heights? Of course, the 3 meters for each story. Otherwise, you can now select customize here. After doing this, now we have these templates. You can create the grids only and so on. Otherwise, for our case, because we have the AutoCAD file, we are going to select blank, this one, then click OK. Click OK. Now, after this, remember there's nothing we've done so far. It's just setting and selecting the code. I want us to let me minimize this one first. I think there is just a problem with this file, but no problem. So what we're going to do, the first thing, we will come here to ETABS model. This is the ETABS model. We are going to save this model as DXF file and close it. So what I'm going to do, you can just Control Shift S, please. Control Shift S. Then you'll come here to online session, which is I think in desktop. Yes, online session. So I'll just give it the name ETABS. Then here you'll save this file as .dxf file. This one of 2018. Please remember this. This one. Good. So after that, I'll just click save. After saving the file, I can just close this one because it will be so difficult for ETABS to read a file that is already opened by another file. So I'll save like that. Then I'll come to ETABS. So now listen to this, because now this is, remember, I'm doing this, it's like I'm handling a very complex building, but we are doing it using a very small building. Why? For understanding, because don't expect some simple buildings out here. Out here, you'll be getting some complicated building, curved beams, curved slab, and so on. So to tackle that, you have to understand what I'm going to do. So the next thing is now to import the architectural plan. But before importing the architectural plan, remember in AutoCAD, before doing anything, we first of all created the environment for this architectural plan to be accepted. What do we do in AutoCAD? We created the layers, we set our units, and so on. So for this one, we are also going to create the layers. And what are these layers? The materials. So to create the materials, it's now what we call define. You go and define the materials. So I'll come here, please pay attention. We have so many things that we can define actually, but we'll start by materials, then we'll come here to sections. So for the materials, by default, you'll get some materials. You have steel, you have concrete, you have rubber, and tendon. What is a tendon? Tendon is a pre-stressed member, like the bridge girders, the beams, and so on. Those things that have already been prepared. Is level 2, is never. If it's a bridge, you just come up with that beam, then you put it there. Then the process continues. That is mostly Chinese construction, way of construction. So we are going to create these materials. So for these materials, of course, we have some materials here. Now, I want you to listen to this because it's good to create new materials, but because of time, I want to use what we have to come up with what we don't have. Okay, I think that point is still at home. So to use what we have now, these default materials, we are just going to edit this. Like this concrete, we are going to create a class of concrete that will be used for the design. So I'll just click this, then I'll modify, show material property, this one. Then the name of the concrete, I'll just name it class C25. C25 will be used for beams and slab design. Remember that beams and slab will be used for, we will use class 25. Then for material type is concrete, of course, but we have several materials. We have steel, aluminum, cold form, rebar. Rebar is a reinforcement bar. We have tendon, masonry, and so on. Now we will create class 25. Then here you'll have to enter the density of concrete. In our Excel, I closed it. We used 24 as the density of concrete, if you can remember. We used 24. Then the modulus of elasticity, you just leave it as it is by default. Poisson's ratio is 0.2. This one is in BS at 110 code. When you go to class 2.2, you'll get this one. Now, after setting this, what is the best important thing here? define property data. This one, click modify show material. This one, please be writing down, or I don't know. I think, let me check if we are still recording the session. Okay, the code, we are still recording, so that's okay. So the name of the material is class 25. Then the grade, you just put here grade 25 of concrete. Then the cube strength, compressive strength, you'll just use 25. Then click OK. Then click OK. So that's the first material that we just created. Now, after creating this material, the next thing to do is to come up with another material, a copy of this material. And what is this copy of the material? What you're going to do, you just add copy of the material. Like the properties are just the similar, but you are going to change the name and the class of concrete. So you'll just click add copy. This is not a mat. This one is C30. For columns, we'll use class 30. Density is 24. Then modify material properties. Here we'll change 30. Then we'll have to change the strength to 30. Then after that, click OK. So we have two materials, for the steel and for the slab and so on. Now we have the rebars. In Kenya, remember in BS 110, we've been using the strength of steel. We've been using 500 and 460. That is what we have. Then for the stirrups is 250. But now when you come to, for example, Kenya here, we have now shifted. We are now using a steel material of strength 500. So I'm going to create that one, but you can do the same to customize the same as per the producers of your country. So for this rebar material, I'm just going to modify show material property. I'll just rename this one, that is FY of 500. Then it is a rebar. Rebar means reinforcement bar. Then for the unit weight, this one is perfect. Don't touch it. Now be changing this. I'll change this one to FY 500. Now this is important, this part. The FY, of course, is 500, the yield strength, that is the minimum. Then the FU, to get the FU, you'll take FY, which is 500, then you multiply this by 1.25. Please remember this is very important. 500 multiplied by 1.25. Then the good thing with the civil 3D, this one, what is this? ETABS. This one is ETABS. The good thing with the ETABS, as I type this formula, when you press enter, the answer will just come. Then FY, this one is with 6. You now take FY, FYE. You take FY, I will start. FU, you take FY multiplied by 1.25. FY, you take FY, FYE. This one, you take FY, which is 500. Then you multiply it by 1.1. Then you press enter. Then lastly, FUE, you take F, which is 625. Then you multiply this by 1.1. So remember, the first one you multiply it by 1.25. This one 1.1, this one 1.5. For this one, you just look at FYE is just FY multiplied by 1.1. FUE, you take FU multiplied by 1.1. That is all. If you have any question, please let me know. It's a very mighty request, but remember this because it's a very important information for ETABS. Then after that, just click OK. So we'll use this one for both for the two materials. So what I'll do, okay, I'll just click OK because now we are good to go. I'll just click OK. The next thing is to create the section properties. So after creating all these things from AutoCAD, it's now very simple because ETABS is going to recognize the column and it's going to pick them as we defined. So here we are going to define the section properties. We have the frame section. What is a frame? Frame is a combination of, is a skeleton of beams and columns without slab. Beam, column, that is frame. Tendon, as I said, as you can see, this one is something like a circular beam, and this beam has some reinforcement inside. So we are not going to do this because we are not doing the bridge or whatever. Then for the slabs, we'll create the slab section later, a slab section of 150, and we don't have the deck. Deck is for slab. For the bridges, walls, we don't have shear walls here, and then we'll define reinforcement at this point. So we'll start by creating the frame properties. So I'll first of all delete all this. I'll delete this, what we have, because we don't need this. Then I'll just modify this beam. This one is a con beam. This one is concrete beam. So you can just come here, double click. You can double click, or you can here to show properties like that. Then I'll just name it beam of 200 stock 450. That is beam 200 stock 450. By default, the material is C25. That is very okay. Then the best part is now to set the depth and the width, because this is just a name. So the depth of this one is 450. Please remember this. Then the width it is 200. Then we will just use the rectangular section. We are not going for T or L. Please. Okay, most of the things we'll discuss them code-wise. I will take there when we get time. But I want you to understand how to use these two software, practice them, so that next time when we arrange such a webinar, then it will now be easier for you to understand now what are these. After setting this one, so listen to this. We have the reinforcement. You have to set the reinforcement. So you'll click modify show material rebars here. According to ETABS, we have two types of frames. We have columns and the beams. Beams, columns always, we always have three types of loads or forces. The forces, I'll just draw a column here. If this one is our column, sorry, Control Z. Okay, let me pick this one as our column, this one. This column will be acted upon by a point load on top. Then we always have two moments. Go to BSETA 110. Please, you can write down 2 and down. Go to BSETA 110 clause 3.88 design of columns. Then you'll get somewhere written moments in columns. So we have M1 and M2. This one. Then this one is the point load, the compression force. This one, which is the point load on column. So we have these three loads. So these three loads is what you are now seeing in ETABS. We have M1, M2 now, and what? The point load. So as we go to the design, M22, this one is the major moment. Then M3 is the minor moment in columns. But when we go to beams, the sagging moment is the major moment. We will explain this one when we get there. So, and as you can see, the strength, they are already there. This one is okay. Now, listen to this. We have cover to longitudinal rebar group centroid. Now, this cover, I'll just draw something here, because it's good to understand. It's even better if we stop at that point, but you get the point. Now, if this one is our beam, this one, then we all have, this is the main reinforcement one. Then we have the stirrups, this one. Prota will show us this one. Prota and ETABS is going to show us this one in a few. So what ETABS is asking right now, this one, cover to longitudinal rebar group centroid. This time centroid is very important. Very important. So group centroid, what's the point here? They want the distance from the top or from the bottom. This distance, we'll call it D prime. This distance is what is required. So this distance, we always assume the diameter of the reinforcement to be 16. So half this distance is 8. 8 plus the link, the stirrups, is 8. 8 plus 8. Then the beam is 20. So when you take 8 plus 16, which is 8, you'll get 41. I don't know if that math is correct, but I always just put here 41. You'll correct me if I'm wrong, but this one is okay, and then you click OK. So then you click OK. We have our beam. Any question up to that point? Because now this is ETABS. Remember ETABS. So I'll click OK. We've only set our one material. We have not created any column or so. So after creating that material, what is the next thing now? Okay. After creating the material and the section, we've created the beam section. The second thing is now to import our plan to ETABS, and we will see it. We will see it here, and we will also see the plan here. So this plan, we are going to create story 1. In story 1. So as you can see right here under plan here, we have story 5, which is at an elevation of 15 meters. So we want story 1 to be here. How do we bring story 1 here? We have this. Arrows. We have up arrow and the down arrow. How do we utilize this arrow? We just click this on this window here, then they will be activated. Then you can now move to the bottom story. How do we move to that bottom story? You can just go up. Of course, from story 5, it will go. It's like a circle. It will go to the to the 0 story, but we don't want to bring the plan to this. We'll just bring our plan to this story, to story 1 here. So this one is okay. Then whatever we are going to create will be visible here. Now pay attention, because we are now going to import the plan. So to import that plan, it's very simple. It's very simple. You'll come here to this icon, the file, this file icon. Then we have import. What are we going to import? You can import several things, but I just want to go to a direct thing. What is this direct thing? We have this architectural plan. Actually, it is an architectural plan. So you have to import this one. I hope we are still together. So I'll click this one, architecture. We have architectural grids. We are not going to create the grid lines or the plan. We are just coming with the architectural plan. So we have to select the DXF file. So DXF file, I'll go to desktop, online classes, then I'll just select ETABS like that, then click open. Then it will ask us, are your units in millimeters? The answer is yes. To which story do you want to create your model? Of course, we want to bring it to story 1, bottom story, this one, like that. Then all these other things, you can just leave them as they are. Yes, now click OK. As you can see right now, sorry. Okay, what happened? Okay. I don't know what's happening. Just a minute. Okay, let me zoom this one. Okay, zoom, restore this one. Okay, so we have our model here. As you can see, everything, all the columns, as you can see, all the columns and all the beams are here. Now, how do we utilize this to create these columns? Because that's now the best question. And remember, these columns are coming from a ground level to the top story. So we have to tell it, remember that this column is not just coming from here to from story. I created this thing to story 1. What happened? Okay, now I think it's okay to story to this one is story 1 right now. So we are going to tell ETABS that please remember this model is moving from story 1 to story 5. How do we do that? At the bottom here, where we can also change the units, of course, but I don't want to change anything right now. At the bottom here, you have to select all story. Select all stories like that. Then immediately after doing that, now you have to draw the columns. To draw the columns, it's very simple. It's very simple. To do, let me drag it here. What we are going to do in now, we will come here under display, because this one will just be there. Under display, you'll come here to one of them. We have the plan and the 3D. So I'll just open plan, this one. Then we have the architectural layers. Remember, we had so many layers, but now, what layer do you import? Which layers are these? And the good thing is that the colors have also been imported. So as you can see, this is the grid line, which is just the beams. Then this is now the column is here, green. So what are you going to do? Because we have told the software to accept that the columns are moving from 0 to up to the top there, you come here, you select this column, then right click. Then there is this feature telling us add column object, this one. So if I click, you'll just see columns will be populated at this point, and also at this point we will see columns. Let me click and see. So as you can see right here, we have all the columns created. Also here, we have all the columns created, but these are lines. How do we see these columns as real objects? You come here to extruded view. So you click this one, you click on it. Okay, sorry. Click on this. Right now, as you can see, now we have our columns. These are our columns, and these columns have their sizes correct as we define them. So how do we know that? So the next thing after setting your columns, the next thing is now to come here to define. Remember, we never defined any column section. So under define here, you come here. Then what you'll do, you'll come here to section properties, frame sections. Then as you can see, now we have several columns here. So you have to change these names for your understanding. So I'll just double click for each. I'll double click on this one, change the name. This one is a 200 by 200 column. So C200, sorry, I just name this one C200 stroke 200 like that. Then I'll change this one. Remember, for the column, we are using class 30 like that. Then what else? We will come here to reinforcements. Under reinforcements, remember, as you can see, the column is picked because we redefined the columns. Now, in beams, it requested us to give the cover to the centroid of the main reinforcements. That's why we gave 41. But in columns here, it is asking us to give, before we go there, I think this one is okay. And then it's a rectangular column. We are going to use the ties, and we are going to allow the software to design. So under the longitudinal bars, the cover, we are going to use the cover for columns. Mostly, we always use 30. Then, because we are going to tell the software to design, there's nothing here to change. Just leave them as they are. There's nothing to change there. Then I'll just click OK. Then double click on this. It's a matter of changing the names. So this one is also C200 stroke 200 or 250, sorry. C200 by 250. This one, as you can see, we just take from here. I'm checking from here. No guessing in ETABS, by the way. So 30. Then modify this one. It's a matter of modifying, changing this one to 30, and everything is okay. So okay, and then okay. Then second last or third last, we are almost. This one is C250 stroke 200, just the same column, but now the orientation. Remember, orientation is very important. If you don't do the orientation before, it will take you much time to model the structure. You have this one. This one is C300 stroke 200. Then remember to change the material. This one is very important. You can even forget to change the name, but don't forget to change the material. Lastly, this one is 200 by 300. C200, as you can see, I'm not guessing. I'm getting these values from here. Then this one is class starting. Then this one is 200, 300. Then lastly, here, I'll just put 30 like that. Then okay. Then okay. Now, all our materials defined perfectly, and we have them right now set. The next thing is now to come up with the beam. Pay attention to this, because if you don't, you'll end up looking for me again. Now, to set the beams, right now, if I come here to beams, this is the beams, the green line, this one is the beam. If we create the beam right now, we will create a default beam, and that we don't know. So what we are going to do, first of all, we have these tools. These tools, as you can see them here. We have this tool, the one telling you to draw the beam. Just click on it, this one. Then immediately you click on it, then you will see this one up. Now the properties of what you want to do will come. So of course it's a frame. Then the beam property will now pop up. So don't close this one. What you'll do now, come, instead of drawing, because this one is the manual drawing, instead of going to manual drawing, come here, right click, then add the beam object. Just check what is happening. Be checking. And it's assigning the beams according to the numbers. These numbers, we will just see them in a few. It is taking time because I extruded all the floors. It's not good practice to extrude the plan. Perfect. I think up to that point we are still together. If you have any question, please ask, because to get a class like this one, it's not easy. After this, we are going to handle prota. It's just a single class handling two things at now. So what next? Slab. Remember, we didn't define the slab, so we are done with this. We can right click on each element, then hide. But we will only hide the beams what is there. So we'll hide the grids and the columns. We don't want to see them. You just right click, then hide like that. Then for this one, you don't have to extrude the plan, please. So I'll just click on plan, then come here, extrude, then click on it, then they will appear like that. Now, what next? The next thing to do is now to create the slab. Before creating the slab, you have to define the slab. You have to come up with the slab that this is the slab that I'm going to use. So I'll come here to slab, define, then section properties, and then you'll come to slab sections. Then, as you can see, by default, we have two slabs. You have the plank, and we also have the slab one. So I'll just delete plank, then I'll edit this slab one. I'll just modify shape material properties. Remember, from the pre-design, we had a slab of 150 millimeters. Then we are going to use material C25. That is the class of concrete. For the slab, we have three modeling types: shell thick, membrane, and layered. Please get time and we can have another comprehensive where I can cover this. But always, as much as you are an engineer, please be using shell thin for slab, shell thick for shear walls. And these others, we'll discuss them when to use, but for now, don't use them, a request. So we'll use shell thin for slab, then shell thick for shear walls. Then after that, it's a slab of 150 millimeters here, like that, then click OK, then OK. After this, you cannot, okay, let's try and define the slab. When I come here, this is the tool for defining the slab, the quick draw floor, this one. Make sure you use this one because we want to draw them quickly. So quick draw floors, this one. If I click this one, of course, we'll have to select this one, then select your slab like this. So if I start drawing, you realize nothing is actually happening. So we have to do something. What something is this? We have to put the grid lines. This you just right click, then you right click anywhere, right click on this, then add modify grids. So the first one is the story data, and then the second one is the grid system, the grid system. So for the grid system, you can just add a new grid system because we don't have, sorry. The grid system that is there by default is grid system 1. If I add new grid system, we will now come up with grid line 2. So we are not going to do this. We are going to modify this one. So I show grid system. Then the grid system by itself, by the name is this one. Then now, how are we going to modify? As you can see, nothing at all, nothing. So we have to use some ways of doing this. And what are these ways? So you'll come here. You see where we have the midpoint of the beams. That is where we should be creating our grid system. So what I'm going to do, I'm going to hide all the columns from the plan. So to hide the columns, you'll just come here to select. First of all, you have select them. We'll select the columns by object type. Please look at this. Select again, then by object type where I am. Then you'll now select all the columns, then click. Okay, after, I don't know, we should be selecting from the ground here. Okay, select by object type, and then columns. This. Okay, no problem. Then right click outside, then click outside, then hide. Where is hide? This one, hide selected objects. Good. As you can see now from the plan, we can't see the columns. Now, what is the magic of creating the grid system right now? So you'll come here where the beams are meeting. Okay. I think now there is a problem. You have to select these nodes, but I don't know, they are not selectable. Okay, let's show all objects and try using the columns. But a good practice will have been. So I'll just come here like that. As you can see now, you have the point selected. Also, you can check from here. We'll select this one. But as you can see, this one has selected 2 points, but we only want one. I'll show you the easier way of doing it because, okay, this one now. Okay, how do we go about this one now? Okay, let me select this one again and see. Let me just select one by one. But now there is the easier way. There's a step I skipped. You have to select all these that I'm selecting, not the beams. As you can see right now, I'm also selecting the beams, which is now wrong, but it will still work. But we don't have to select these 2 points. Okay. Okay. For the internal columns, I think that is a symbol. I'll just select all the columns for the internals. For the internals, it's simple. But please, I will show you the easier way of doing it because there's a very important step that I forgot to monitor. So, yes, Josephat, do you have any question?
Hello, engineer.
Yes.
Node selection cursor is not
Yes.
active. Node selection cursor is not active.
On my side, or I don't.
Your side.
Okay, how do I do that?
ETABS.
Yes.
ETABS. Below file, there are two cursors.
Yes.
ETABS, then there's one cursor which is highlighted in blue, and then
Yes.
below cursor. I think that cursor should be active so that
Okay.
it will select the nodes.
Let me finish, and then you will tell me because just 1 minute, please. I want you to advise me. Just a minute here. Now, anyways, let's assume everything is okay up to that point. Then, after doing this, you'll go to edit. Then there is this add grid lines at the selected joints. But let me do this. Then I'll get the advice from our colleague. So I'll put them in X and Y direction. Then I'll just apply and click OK, like that. Now, engineer, please tell me the point because you had a very good point.
I was saying that the node selection cursor
Yes.
was not active.
So
I
how
think
do
it
I?
is not. I think that is a node selection cursor. Below file, there are two cursor. No,
Here.
any
Yes.
below file. Do not click file. Just go to the icon which resembles this cursor which is moving
Okay.
on your left side.
On my left side, this one.
That one.
Okay.
Is that not node selection cursor?
No. This one is reshape object. Then this one is select object.
Oh, I thought it was used to select the nodes.
No. This one, you see the first one
Mm.
uh, is used to select, just select general object. Like you can just select all the objects like this. But now for the points, we have been concentrating on how to get the points, the exact points. But I'll discuss that one. It's very simple. There's a mistake that I skipped. Sawa.
Okay.
Now, I think this is okay. Let's edit. Let me edit this, then see if they will work. So this, as you can see, things are so bad. You'll come here to add modify grids. I'm faster, but I'll show you the easier way. There's a very important way, the procedure that I skipped. Now, grids in X, we only had A, B, C, D. So what I'll do, I'll just come here. You don't use this one, use this one. Display grid data as spacing. Then anything that has 0, you have to delete. So for example, for this 0, you'll delete this one. Then, I don't know which grid is this one, but we'll just leave it for now. We'll delete this one. We will delete also that one. Then the last one must be 0. So we have 4 grids, 1, 2, 3, 4, and that is A, B, C, D. So this means this one should be D, this one should be E. Then, so there is a problem here. I can see 0.025. Okay. Let me check our model. 1, 2, 3. Yes. Now, there is some split. I think. Well, A, B, C, D. Look at me now. Okay. This is D. This is C. Sorry. C. This one is B. Then this one is A. But so now there is a problem on these two grids because this value should be added to this. But I think we can edit this. Let me just delete that. We will edit them later. Then for this one, I'll delete this. Though, remember, I'm going to show you a very perfect way of avoiding these stupid errors. So for this one, we have 1, 1, this one is 2, this one is 3, this one is 4, this one is 5, then the last one is 6. So after that, just click OK, like that. Now, as you can see, as I was saying, this grid, there is a problem with it because as you can see, this one has shifted from the main point. It's now here. So what we can do, we can just edit, we can just remove this grid, the first grid. Then, okay, I think that it has now selected that. I'll select this one also. But please, I'm very sorry for this. Just remember, I have a very nice way of not complicating things. Wesley, are you still in the meeting? Ama ulitoka? So I have
I'm here,
selected.
Jake. Sama.
Oh, good. So I have selected this first, the first grid, only this grid line A. Then I'll just go to edit. I'll add grid, but this one I'm going to add it in X direction, parallel to Y, not X, parallel to Y. Then I'll just click OK, like that. So this grid that is now parallel to Y, it's named, it's given a certain name. So I'm going to move the other one. But please, let me mention Wesley because Wesley understands what I'm doing. So for this one, I'll remove 1. I'll remove this. I'll remove this. The same problem. Okay. Let me not click OK. Let me modify and see what could have been the problem here. Okay, let me delete grid line, all the grids in this direction like this, and click OK, so that when I add, so let me select, please, so this is the mistake that I was saying. You should not select 2, you have to select 1. I'll select this. There is a very simple method, I don't know, I forgot. Now, I think prota will take us 30 minutes. Even ETABS, the moment I finish this one, it's just to put the loads and then to, so I'll just add grid at the selected object parallel to Y like that. Then now, I can now edit. I can now edit. edit this one. So I'll come here like this, and then I'll delete this. So this one is A. So I think by that at this point we are now good to go. So I was trying to look at to come up with the right figure. If these values are too small for you to see them, you can also edit them. You just come here to options, then you can come here to graphic preferences, this one. Then you can increase this one to, let's say, 12, this one to 12 also, something like that. Yeah, I think this one is now observable. Now, so with these grids, we can put the slabs. How do you put the slabs? Now you'll come to this floors, this one, very fast. Remember, all stories are on, so this means I'm going to put the floors on our all stories. So as you can see, even without clicking, it has highlighted. Remember, we have a staircase here. So slabs, as you can see, they are coming. Okay, and here. Now, we have these 2 points. Please remember what I'm doing, because this one, Wesley has done a lot of very serious projects with me, and he can confirm that this is the best of doing ETABS. So here at this point, you have to put the slab. But since you have this grid too, this grid will split these two slabs. We'll create one slab here and another one here. That is a wrong practice. So what we are going to do, first of all, hide this grid too, then to have a complete slab. So to do that, just modify show. Then grid 2 is this one. Click on it, then you can visibility, you can just say no, then click OK, and then OK. Then after that, place your slab and you'll get it back. And remember another thing, in all softwares, modeling is the worst part. In all softwares, all. So at this point, please, are now here. Everything is now modeled perfectly. Let us put the loads. After loads, we perform the design. Then we take 30 minutes in prota. Then I think we will call it a day. So perfect. So with this one, we have our slabs, but now we should not be having, as you can see in 3D, we should not be having the slabs at the bottom story, at the ground level, at the ground level, no slab, because structurally we don't always design these bottom slabs, these ones. So what I'm going to do, I'm going to delete them. How do we delete this? First of all, you have to select one story one, then come to plan, then make sure you take this one from story one, now go to story 0. Story 0, so how do we do that? You just use the down arrow. As you can see, right now we are at story 0. Select everything, then delete. Like after this, we have to put to put the supports to our foundation, like to put the foundation. So our foundation, we always fix them. So to do that, select all the nodes like this, then come here to assign, joint, restraints, this one, assign, joint, restraints, assign, joint, restraints. Then, as you can see right now, it is pinned. If we select translation only, it's like we are pinning, but you have to prevent translation and rotation. So to do this, just fix them using the first one like this, then click OK. So at that point, we are good to go. The next thing to do is now to check. If you can remember, in my first presentation, I said we have to check the model immediately after modeling it. So how do we check the model in ETABS? You come here to analyze. Then the first thing is to check. Click that one. Then make sure that all these things are checked. So how do we do this? You can just, first of all, the tolerances, that's okay. You can just check them one by one like this. We have to click check selected object. I mean, we have to click this one, but I don't know. So I'll just click OK. Then it will take like some seconds or so. Then it will perform the checks. So as it's performed the checks, let me just crack this software, this other software, because we are moving there. With the prota, we are going to take like a few minutes. So, Control C. Okay, you just after installing the software, you just have to copy these patched files, then go to your desktop. As you can see, the model has been checked. No warning or messages were generated, so the model is now perfect. Let me minimize it first. This is the prota. I'll just delete this. This is prota. I'll right click, open file location, then copy these two files in here. Paste. Override. That's okay. So I'll be opening prota as we finish ETABS. Prota is here, this one. So now in ETABS, I think up to that point go. So what we are going to do, we are now going to assign the loads to our structure. How do we assign the load to our structure? Let's start by assigning the loads to beams. To slabs, I mean. So to slabs, first of all, you have to select all the slabs. You have to select all the slabs. So to select all the slabs, as I said, you just have to select. You know, ETABS is like, we are just talking English. Select, that is the term. You have to select all the slabs, and the slabs are objects or elements. So you just have to select by object property, then go to floors, then select. As you can see now, all the floors have been selected. If you can come here to ground floor, you can, as you can see, all the floors are selected. After this, come here to assign. We want to assign the loads. So we have two types of load. We have dead load and live load. But before we go to assign, let me just show you. So apart from defining the material and the sections, the next thing to define is the patterns and the load combinations. So the load patterns here, we always have, by default, we always have two load patterns, dead load and live load. And for this small building, that is enough. Otherwise, to kifanya a very serious building like 20 plus or 15 plus or 10 plus, then we must include some factors or some loads like wind loads, earthquake loads, other type of load that is necessary for our design. So for this one is just okay. Then we will come here to define again. We'll come here to define. Okay, let's define some load patterns. Let me just show you. We are going to define dead load here, dead load. Then we will also define other load. Sorry. Now, which load, the name of that load, we are going to define SIDL. SIDL, as we said, this one superimposed dead load or a wall load. Let me just, superimposed dead load. This one is the load that is now coming to the slab. This one, so I'll just add. Then, as you can see, the factor, Control Z. Let me delete it. Superimposed dead load, the factor is 0. Superimposed dead load. This one is super dead. This one, the super dead. Super dead. The self weight multiply is 0 because this one is not the self weight of the structure.